a busy day today. When you've got a concept that involves a lot of possible combinations, I think one of the best things to do is to try and show you as many different situations as possible so that you can get used to how to deal with it. So as we go through the questions today, I don't want you to focus on how did I solve this question in particular. I want you to focus on what was the method that he used, so that when you see another question that might not look like this, probably won't, you know the method and you'll approach it the same way. So what I'm going to do here is step one, which is basically differentiate all the pieces. If you differentiate x squared, you get 2x. If you differentiate y squared, you do get 2y. But isn't there a rule that when you differentiate something with a y in it, don't you finish with a dy by dx? So do you notice then that there's a little bit of difference between the answer when it was pure x's and the answer when it had pure y's? Now this little guy in the middle, well, he's something a little bit different. Isn't that two things multiplied together? And so when you do two things multiplied together, that means that you're going to have to do the product rule. So that guy got me 2x, that guy got me this, but won't this fella be a product rule? I tend to do things like these pieces on their own. And I go over here and I say, okay, I want to differentiate this guy. And I know it's going to be f dash g plus f of g dashed, and this whole chunk's f, and this little bit's called g. So when you differentiate negative 18x, you get negative 18. There's g. Then you put in f, which is that one, and you differentiate the g. And if you differentiate y, you get 1 dy by dx. And so the derivative of this expression is negative 18y, negative 18x dy by dx. So you actually get two terms. And now I can go back to here. And we have 2x, that guy, that guy, that guy, and that guy equals, and when you differentiate a number, you get 0. So far, so good. Right? Differentiate all the pieces with respect to x. Now, that typically is the end of calculus. What is going to happen from now on is pure algebra. And what we need to do here is we need to eventually get dy by dx equals, right? That's our goal. And it's a bit like solving an equation. And so what you should do in this, oh, I forgot my little x there. What you need to do here is collect kind of like terms. So that doesn't have a dy by dx, so I'm going to subtract it from both sides. That doesn't have a dy by dx, so I'm going to add it to both sides. And now I'm left with terms that do have dy by dx in them, and terms that don't. And then there's two more lines and you're finished. And it's pretty much the same two lines every time. What am I going to do next? We'll do it right here.
You're going to solve for dy dx.
Okay, so how about pulling out dy by dx as a common factor? And what do I do to both sides then to solve, to find dy by dx?
Divide by negative 18 plus 2y.
It's not uncommon that this answer is as good as it can be. But you should always be on the lookout for style points, shouldn't you? And that means, is there any way I can make this just a little bit prettier? Does anybody see anything?
I have a question.
Yes.
Where did the negative 18y come from? Because the line before that, it was negative 18x dy over dx.
No, The negative 18y came from here.
Okay,
And then
and then
I
the
added
next
it.
line.
Right, so from this line to this line? I'm trying to think what your question is. What
Yeah,
is confusing you?
I think I'm confused why there's a dy over dx following the negative 18x, because I thought if
So
it was
what's
a
this?
y, then it would have that.
You know, so the question is, where did this guy come from here?
Yes.
Okay. What I did is I differentiated this middle term, which is this guy here, and it's a product rule. So it's a negative 18x and it's a y. So two things multiplied together. If you want to differentiate them, you need to do a product rule. So here's my product rule. If you differentiate negative 18x, you get negative 18 times the untouched g, so that's this guy, plus the untouched f, which is this guy, times the derivative of y. Now, when you differentiate y, you don't get 1. When you differentiate y, you get 1 dy by dx. When you differentiate y cubed, you don't just get 3y squared. You get 3y squared dy by dx. If you differentiate y squared, you get 2y times dy by dx. And now when you differentiate 1, you get 1 times dy by dx. Whenever you differentiate anything with a y in it, the answer contains a dy by dx as well. And that comes from the properties that when you differentiate anything with a y in it, it's a bit like a chain rule. It's 3 something squared times the derivative of that something. In this case, the something is y.
Okay,
So
that makes sense.
that's where
But
this
when you
came
pull
from.
out the dy over dx, why does it turn into a negative 18y instead of a negative 18x?
Oh God, you're asking why do I make mistakes? This is a totally
I think
different
that's what I was
question.
confused about, because it seemed to
No,
change.
work on the first principle that I've just wrote the thing down wrong before you start thinking, oh, there's some new math going in here that I don't understand. It's much easier when you do that, because isn't that just a typo? Can you see it?
Okay,
Which
thank
would
you.
confuse you. Why did it turn into y? And I was thinking it was to do with stuff up here, but it wasn't. It was just to do with me transferring it. Right, back to the question here. Is there anything you can do to this guy to make it pretty? Because there is. So what is it? You can see anything? How about a comment? Say again?
Can factor 2.
And I'll try and do that. Right. So if you do that, you get this guy. And if you factor out this one, you get that guy. And they disappear because they cancel. And I know it's not much of an improvement, but would you agree it's a little bit nicer than it was a minute ago? So that would be the kind of ultimate version of the answer. Okay. Practice makes perfect. Let's try this fella. This is a version of question 3. So it's x to the 5 plus x to the 4, y to the 4, plus y to the power of 9, and it's going to equal 6. So we're going to differentiate each of these guys. If you differentiate this guy, you get 5x to the 4. If you differentiate this guy, you get power rule multiplied by power reduced at 1 with a dy by dx equals, if you differentiate this guy, you get 0. And over at the side, I'm going to differentiate that. Would you agree that's another product rule? Not unlike the one we just did. So this is f, this is going to be g. So if you want to differentiate it, it's f dash g plus f of g dashed. And if you differentiate this guy, you get 4x cubed. You leave that guy alone. You leave this guy alone. And when you differentiate y to the 4, you get 4y cubed. Anything else? When you differentiate y to the 4, do you just get 4y cubed, or do you get 4y cubed and something else?
dy dx.
dy by dx. So those guys fit in here. So what I'm going to have, plus 4x cubed y to the 4 plus 4x to the 4 y cubed dy by dx. Add. These two terms do not have a dy by dx. So I'm going to subtract this guy from both sides, and I'm going to subtract that guy from both sides. So I'm now going to have this term plus this term. And if you subtract this from both sides, you get that. And if you subtract this from both sides, you get that. I would hope that once you reach this line, it becomes kind of mechanical. Isn't there going to be 2 steps? And some of you, after a while, do it in 1 step, don't you? Because you just know what's going to happen. But we'll take it slow. What should I do in my next line of working? What should I write here? What should I do here?
You factor out dy and dx, and then do you also factor out y to the third, or
No. That can come later, but don't do it right now. Basically, just always factor out a single dy by dx. Other things that might happen, we'll do at the end. Now, at this stage here, then, isn't the last line pretty much the same thing every time as well, isn't it? So I would divide both sides by that horrible mess. And I'll move it over here because I think I'm going to need some room. We should try and do some style points. And typically that's going to be common factors. So if you look at the top expression, would you agree x cubed is a common factor? So I'm going to pull that out. And that's going to leave me with negative 5x, take away 4y to the 4. And on the bottom, I think I can pull out a y cubed. And if I do, that leaves me with 4x to the 4 plus 9y to the 5. And that's it. Nothing cancels, but it looks prettier than it did. Are we good? Any questions? We're sticking right now, we're sticking to polynomials, right? Powers of x and y. So we need to kind of move on and try something that's not a polynomial. So here's a version of question 5. Differentiate everybody with respect to x. So if you differentiate x, you get 1. If you differentiate negative y, you get negative 1 dy by dx.
Yes.
So I probably wouldn't write that negative 1. What method will I use to differentiate this guy? How am I going to differentiate this guy?
in row?
Okay, so FG. So it's going to be f dash g plus f of g dashed. If you differentiate this guy, you get 1. Leave the other thing alone. Plus, leave that alone. If you differentiate e to the y, you get e to the y times dy by dx again. Every time you differentiate with a y, you always finish with a dy by dx. So we're going to get this guy plus this guy. So step 1, pretty much the same every time. Differentiate everybody. What should I do next?
dy dx over about the same side.
Okay, so it doesn't really matter which side, but I kind of like the left because I just kind of like the left. So if I'm making sure all the dy by dx's are on the left and things that don't have a dy by dx end up on the right, what I'm going to do is I'm going to leave that guy alone and subtract e to the y. I'm going to leave this guy alone. I'm going to add a dy by dx to both sides. So that was a little bit of moving things around, right? And then finish with, pull out a common factor. Divide both sides by whatever is in the brackets. And I'll rewrite that again. And if you can't do anything else, you're finished. But if you can factor things or combine things, whatever, you should do it and make it look pretty. Now I'm going to give you a sneaky question. This is question 4. And I'm going to call this a made-up name that I use. And this is a question which falls into the category of just because you can doesn't mean you should. If you were just following blindly the differentiate with respect to x and then do what you need to do, that side is really nice. Can you imagine that you'd have to do a quotient rule with the left-hand side? Aren't quotient rules almost always really ugly when you're finished? And in this case, really ugly makes a big problem because don't you eventually have to solve for dy by dx? So wouldn't it be a good idea to avoid having to do a quotient rule? So just because I could do the quotient rule doesn't mean that I should. So what I'm going to do is I'm going to call that guy that fella. And now I'm going to cross multiply. And so what I end up with is x plus y squared plus 7 is equal to x squared. And I'm going to take this guy and I'm going to FOIL him out. And so you're going to get x squared y plus 7x plus y cubed plus 7y equals x squared. And just in case there anything combines, no, I don't. Would you agree that although this question is longer looking, wouldn't this be much easier to do? Because isn't it like all the other ones we've just done? So wouldn't that be a product rule? Wouldn't that be a 7? Wouldn't that be a 3y squared dy by dx? Wouldn't that be a 7 dy by dx? And wouldn't that equal 2x? And ... You would finish the question in the usual way. Let's put some trig into the mix. So it's going to be the sine of x plus the cosine of y, and it's going to equal 7x minus 2y. Things are looking good, so I don't need to do anything to alter the way it looks, I can go into differentiating each piece. If you differentiate a sine, you get a cosine. If you differentiate a cosine, you get a negative sine. Is that all you get? Is the answer just negative sine, or should there be more?
There's a y, so you have to add dy dx.
Yeah. And I know I'm flogging a dead horse here, but trust me, the number of times people forget that little piece, I've done it myself, it's just too many times. And if that piece is missing, your answer won't work. Now, if you differentiate -2, you get -2 dy by dx for the same reason, right? If you differentiate anything with a y in it, you finish with a dy by dx. And we'll, get everything together. So adding 2 dy by dx to both sides and subtracting cosine x from both sides, we now have that. Then I can pull out the dy by dx as a common factor, as you always do. And then I can simply just divide. Do you think there's anything you can do to that fraction? Can I make it prettier? Can I do anything to it? No. Sometimes you have to know when there's nothing to do, right? We're finished. There's nothing else you can do to that. Now we're going to look at a new situation, one that we haven't seen. Implicit differentiation. That involves chain rule. So we're going to look at how do you differentiate questions, expressions, where the chain rule is going to be part of that process. So let's just give you an example of a situation. Let's suppose I'm differentiating something and that's one of the pieces. So we're just focusing on what you get when you differentiate it, right? We're not doing the big picture, just one piece of the puzzle. Differentiate that. Well, if you take a cosine and you differentiate it, don't you get negative the sine? Now this is the cosine of something, so its derivative is negative the sine of something, times the derivative of that something, right? That's essentially what the chain rule says, isn't it? Put the answer over here. So it's negative the sine of x squared plus y squared times. The derivative of x squared plus y squared gets treated slightly different. The derivative of the x squared is 2x. The derivative of the y squared is 2y dy by dx. And that is us finished for the time being, because all we're going to do here is focus on differentiation, none of the other steps yet. You comfortable with that? Suppose you got an expression that looked like e to the power of y cubed, right? That's one of the pieces that you needed to differentiate. Then it's e to the something. So it would be e to the power of y cubed times the derivative of y cubed. That's e to the power of y cubed. And if you differentiate y cubed, you get 3y squared dy by dx. Comfortable? Suppose you got sine x plus cosine y cubed. Again, that's a chain rule. Something being cubed. 3 somethings squared times the derivative of the inside function. So I get 3 sine x plus cosine y squared times, if you differentiate the sine function, you get cosine x. If you differentiate a cosine function, you get negative sine y times, guess what? A dy by dx. Do you see the theme that's going on here? Right? You differentiate x's the way you always did. You differentiate the y's almost the same way that you do in x, but remember to stick on a dy by dx at the end. Right? That's essentially the structural difference between those two situations. Right, let's put one of these into practice. This is question 8. Cosine of x add y is going to be equal to the sine of x plus the cosine of y. If you differentiate the cosine of x add y, you get negative the sine of x add y times the derivative of x add y. If you differentiate a sine, you get a cosine. If you differentiate a cosine, you get negative the sine of y times the derivative dy by dx. So I've got this guy times, if you differentiate x add y, the derivative of x is 1, the derivative of y is 1 dy by dx. Now, when you have chain rules, as we do here, the algebra can be a little bit different. I know the final goal is somewhere down here. I'm going to write down dy by dx equals, right? That's where I'm going to end up. But there's a lot of things between here and here to get me to here, right? I can't just do it in one line. I wouldn't even attempt. So you take each line and you figure out what you should do to get closer to here. So what do you think I should do, especially with this expression, that guy times that guy? What would be a pretty decent move to make? What would you think? Negative sine of x plus y times 1 plus dy by dx. That's what that says. What do you think I should do with these two guys?
Because there's so many ones, I would try foiling it out.
Okay, so negative sine x add y times 1 gives me the negative of sine x add y. And negative that guy times this guy gives me negative the sine of x plus y dy by dx. And these two guys are still the same two guys. Now what I see is I got this guy, which I kind of like because I like them on the left-hand side. And I've got this guy, which I wish was over here. And don't we have this guy who doesn't have a dy by dx on it, and this guy here who doesn't. So I'm basically going to move things around by adding or subtracting from both sides. So to get rid of this guy so he comes over here, all I'm going to do is add a sine of x add y to both sides. And I want this guy to disappear and move over here, and so I'm going to add a sine y to both sides. So add a sine y dy by dx. And this guy can stay exactly where he is. Right. Can you see each step of this process is getting me closer and closer to here? Okay, nothing to see here, but there's some stuff here that can be dealt with. And this is pretty standard, aren't we, down to like the last two lines kind of thing. What should I do here then? What should I do here?
Factor out a dy over dx.
Are you beginning to see a pattern of working where you kind of do, that's a lie there, where you kind of do the same thing, even although it's different questions? And don't you almost always end up pulling out a common factor of dy by dx round about here? And once you do that, isn't the next line also pretty much you end up doing the same thing? What do I need to do to both sides here to find dy by dx? What should I do to both sides to find dy by dx?
Divide.
Okay. By that ugly expression. And there isn't anything you can do to that make it look pretty. If you think you could, oh, can I not call that the sine of x plus the sine of y? You're not allowed to do that, right? Sine functions pretty much track whatever's inside them, right? So if I had said the sine of xy, I still wouldn't have been able to do anything to it, right? Any questions? Any questions? Okay, I think that's a good sign. I'm hoping it is. I haven't introduced, I don't think anyway, a question that has a square root in it. So we don't need to worry about trig guys anymore, but we do have to worry about square roots. Every time I can think of that I've ever had to differentiate a square root, don't I have to call it a fractional power? So I'm doing that before I even think about the next line. So now I've got that. If you differentiate this guy, multiply by the power, reduce it by 1. If you differentiate y to the 7, multiply the power, reduce it by 1, and don't forget your dy by dx again. This is a chain rule. It's not x to the half, it's x add y to the half, right? It's something to the half. So it's a chain rule. So it's 1/2 something. Well, if you take 1 away, you get that. Followed by the derivative of x add y. Well, the derivative of x is 1, and the derivative of y is 1 dy by dx. So I'm going to write that. And we have finished with the differentiation. What we haven't done yet, because there's a lot of work and some of it is kind of different, is we haven't got anywhere near isolating the dy by dx. There's a lot of stuff going on here before I would even think about that being an issue. And it's all algebra. It's all style points. I kind of like the right-hand side, so I'm not going to do anything really to the right-hand side. I like it. I do not like a half, something to the power of negative a half times 1 plus dy by dx. Would you agree that is, that's not good, right? That's just not good. So I'm going to call this 1 plus dy by dx. That 2 is coming downstairs, and I'm going to call it x plus y to the half. And that's now going to become, I'll turn it back into the square root. Okay. That's a weird looking guy. Any ideas how we can make it less weird? Does this help? Oops. Does that help? You're smiling, Vanessa. Do you know what I'm trying to give people clues here?
To cross multiply.
I'm going to cross multiply. So this guy times 1. And this guy times this guy. Well, that's a lot messier. This guy times all of this guy. I bet you when you signed up for Calc 1, you didn't know you were signing up for algebra with bells on, right? Have you noticed that a lot of the things we are doing is actually algebra, right? Making things look pretty. Now, I kind of like the left-hand side. What do you think I'm going to do with this? Put the bracket in the wrong place there. What do you think I'm going to do with this?
Foiled it.
Yep. This guy times this guy gets you 14. The square root of x add y, x to the 6. And this guy times this guy gets you 14 square root of x add y, y to the 6 times a dy by dx. We are very slowly getting to where we need to be, right? I don't need the details here, but roughly, what am I going to do next? I got this equal to that. What would I do next? I've done it in all the other questions as well.
Start shuffling around
Yeah.
the dy dx's.
Yes. Shuffling around is a good term. I'll take this away from both sides. And that's going to equal this guy. Take 1 away from both sides. Then I'm going to pull out the common factor. We're on the home stretch here. So I'm going to pull dy by dx out as a common factor. And then I am going to divide both sides by this. And I'm pretty sure that you can't make that pretty. Would you agree that is just a mess? But it's the answer. How are we doing, guys? Are you still hanging in here? Implicit differentiation. I mean, the more you see, the better you get. Well, there's one last type of question. How to find the equation of a tangent line. So you're going to be given a function and you're going to be given a point and you're going to be asked to find the equation of the tangent line. So here is an example of that. This is a version of question 13. You're going to have y e to the power of sine x, and it's going to equal x cosine y. And we're being asked to find the equation of the tangent line at the point 0, 0. So the way we're going to tackle this question is, I'm going to find the derivative dy by dx. I'm going to plug x is 0 and y is 0, and that'll give me the slope of the tangent line. And then I use the point slope equation and we're done. I wish it was a very short question, but it is not. So I'm going to differentiate, oops, start again. I'm going to differentiate this guy, this piece first. Y times e to the sine x is a product rule. So that's f and that's j. So if you differentiate just this term, you get f dash j plus f g dashed. If you differentiate this guy, you get 1 dy by dx, and you leave the other guy alone. You leave the first fella alone, and if you differentiate e to the sine x, isn't it a chain rule? E to the sine x gets you e to the sine x times what? What's the bit that you add at the end? E to the sine x times come on, guys, there's only a few more years to retire. I'd like this class to be finished before then. What goes here?
Cosine x?
Yes, thank you. It wasn't meant to be a trick question. There we go. And that's it. So this fella here is a dy by dx with an e to the sine x plus a y e to the sine x times a cosine x. Now, if you want to differentiate x cosine of y, that is also a product rule. This is f, this is g. Stick to my red again. So it's going to be f dash g plus f of g dashed. If you differentiate x, you get 1. If you differentiate the cosine of y, you get negative sine y times the dy by dx, because it's got a y in it, right? Plus, you leave that guy alone. Start that again. This is 1, you leave that guy alone. This guy, and then you differentiate the cosine. And the derivative of the cosine is negative sine y dy by dx. And I'll try and make that a little bit prettier. It looks something like this. So over here, I will do cosine of y, take away x sine y dy by dx. Okay, now we shuffle everything around. Kind of like that phrase. Shuffle everything around. So I'm going to keep that guy because I kind of like where he is. I'm going to subtract this from both sides. Keep that guy, I like where he is. So subtract y e to the sine x cosine x. And I'm going to add this to both sides. Then we are in the last two lines. Pull out this guy as a common factor. I'm really doing him with this fella, so just write him down again. And then divide. So the derivative is this fella divided by this fella. And for many questions, that's all they wanted, but not this time. We want the equation of a tangent line passing through 0, 0. So I'm going to find what the derivative is. That's the slope of the tangent line when x is 0 and y is 0. So it's going to be the cosine of 0 take away 0 times e to the power of sine 0 times the cosine of 0. Now on the bottom is going to be e to the power of sine 0 plus 0 times the sine of 0. An awful lot of zeros going on here, but not everything is a 0. The cosine of 0 is 1. Nothing times all of that is nothing. E to the power of sine 0 is e to the 1, and that's nothing. And e to the 0, I should say. So e to the sine 0 is e to the 0. What number is e to the 0?
1.
So haven't we basically just got a slope of 1? So the slope of the tangent line to this ugly implicit curve at the origin 0, 0 is just a nice number 1. And the equation of a tangent line, we use the point slope equation to do that. So it's going to be y take away 0, 1 times x take away 0, y equals x. Are we happy about that, that question? You feel comfortable about that question? Let's phrase it that way. Any questions? I don't know, did I show you yesterday what I have put up in Canvas? I may have already done that. I know I've done it with some classes. Have you seen what I've put up in Canvas? Showed it yet, right? So I won't do that. What I hope to do if I can, I don't have a lot of time. No, I won't have time. Okay, put up your last name in chat for attendance. What I was going to do, but I kind of ran out of time, was I was going to put that thing into Desmos in that straight line and show you that it actually was a tangent line, right? That it worked. But you'll have to do that yourself now. And that's it. We have finished implicit. Well, I will hang about for a few moments. Otherwise, bye-bye, guys. See you tomorrow.
Thank you.
You're welcome.
I have a question about 12.
Is that one I just threw away? Let me find it.
Oh,
it.
I don't know.
No, it's not threw away bad. It just
Okay.
kind of stuck in a pile, my throwaway pile.
Okay.
I got it. Here it is. I'll
Okay,
put it on the
so-
screen.
Yeah.
Mm-hmm.
So my question is, at the point where you're at, it's before you multiply that denominator on the left.
Okay, looking at my screen, is it this line?
Okay.
Tell me when we reach the line you're talking about. Not yet?
Okay, it's before you multiply. Yeah, it's when you've got that 2 in the denominator, the 2, the x plus y to
This
the
bit?
1/2.
Mm-hmm.
Okay, so it's when you have that there, at that point, why don't, oh, no, it's before you have it in the denominator. Can you move, you can't move that 1 on top. Okay,
No.
that's, all right.
It's attached to it because of the brackets.
Okay, that's what I was doing wrong. I kept thinking, well, if you just move the 1 over and then it makes a lot of things easier, but.
Unfortunately, it does make them easier, but it doesn't work.
Okay, all right, well,
but
good.
you're allowed to do things that are multiply that you're not allowed to do when you add.
Mhm.
Right? It's just the rules of algebra says that you, I change attack, but a lot of people make this mistake. Oh, cancel. And the answer is very nice. But there's an add involved there, and doesn't the add stop you doing things that you would like to do? On the other hand, if it was 4 2x plus 1s over 3 2x plus 1s, because these are multiplied, now you could do it. You see, there's a situation where things are allowed, and there are other situations where you're not allowed to do it. So you can cancel factors, but you can't cancel adds. And you can move things around in multiplication world, but you're not allowed to move them around quite the same way when they're being added.
Yeah, I didn't realize they were attached, so that clears it up.
Okay,
Thanks.
that's good. Any other questions?
I had one.
Yeah,
I
Vanessa,
was
what you
gonna
got?
see if there's a time like before the midterm that like if there's like an open office hour to like just
I
ask
have an office hour at 10 a.m. every day, Vanessa. Does that work for you?
no, unfortunately, I have a class
Oh.
at 10.
Yeah. The problem with that is I teach a class at 8, 9. My office hour is 10. I teach a class at 11. I teach a class at 12, and I teach a class right after this one, and it doesn't finish till after 2. So I don't have a very big window of when I can help you. I could help you after 2, but you'd have to make sure
On
you.
Fridays, I actually can do 10 because I don't have my class on Fridays.
Perfect. Then I
Okay.
will see you. On Canvas, you'll see a link to it. You can turn up there.
Okay, thank you.
Any other questions? Jonathan, Rowan, do you have a question?
Yeah, I got a question.
Oh, who's
I'll
first?
let Jonathan go.
Right. I'm pushing you a little bit. We can do a couple of minutes, but I have one more class that starts in about 7 minutes. So I'll try my best to do it quick. What is your question?
You bet. 13 on the homework. Let's see what section was it, just to help you out here. 3.4.
What
Can
question?
Numbered 13.
Is it something you can write down quickly or say to me quickly, I should say?
Say say the problem really quickly. It's 4x plus 3 to the third, all in brackets, and then you have times x to the second minus 5x plus 3 to the fourth in brackets.
Okay, so I'm going to put that on the screen. You can tell me if that's what you're looking at.
Oh, not 1/3. It's just cubed.
3.
I should have said.
Okay, no, that's our English language, what I call third and third 3. Yeah, I understand. Right, so I'll make that a 3. So it's that guy, right? We have 3 there. Does it look good?
What I got with this guy was when I did all the steps to get it all foiled out, and I'm pretty certain it's
No. Don't even think about that.
No, like 5 steps down the road. I got it all derived out.
Oh, okay. So
and
let's check that bit is right, because it could be just a little 3 somewhere that you made a mistake, and the method was right. It's just a little hiccup. So if we do f dash g plus f of g dashed, this guy is a chain rule. So when you differentiate him, you'll get 3 lots of 4 plus x, that guy squared, times another 4, because the derivative of that is 4. Then you leave the g alone, which is this horrible mess. And then we'll add the other one. And you leave this guy alone, which is 4x plus 3 cubed, times, and the derivative of this is another chain rule. It's 4 lots of x squared, take away 5x plus 3 cubed, times the derivative of all this, which is, I believe, 2x take away 5. Does that look similar to what you did?
That looks like exactly to what I got.
That's a good sign then. So I'm going to pull out some common factors. There's a lot going on here, but there's 4 and 3 makes 12. So I'm going to pull out a 4 as a common factor. I believe I can get away with that. I'm going to do a 4x plus 3 squared as a common factor. And I'm going to do an x squared take away 5x plus 3 to the power of 3 as a common factor. And when I do that, this is left alive, that is used up, and one of these is left alive. So I'm going to have 3 lots of this fella. And then I'm going to add, and let's see, that's used up. One of these is left. And this guy is left. Does that look similar to what you did?
I think that's where I actually stopped. I got stuck at.
So what you would do then
was
above, because I got it all like, derived out with those,
With these bits.
the two different derivatives, I guess you could say. It was like, that's a lot of stuff, and I don't want to like, manually, this stuff.
Yeah, well, if you do this guy, you're going to have a lot of stuff, unfortunately. Sometimes that's what happens.
Okay.
So I'm
wait.
foiling that out. Now that turns into some ugly quadratic. Looks like it's going to turn into (11x squared, negative 35x, and it looks like take away 6. So that's what I would get. I did that really quickly, so you may want to double check my adding, subtracting, but that's what I believe I got.
All right.
So just, if I understand correctly, we're just pulling out, what's it called, word?
You're pulling out common factors. So
Yeah, pulling out
this
factors.
is a common factor, this is a common factor. And I've just noticed something here. There's a 6 there that I should have accounted for as well. So it's not going to be 35, it'll be 29, but method's still right. Yeah.
Oh, okay. I'm not gonna take up any more of your time. I'm gonna let Rowan do his thing because I
Right.
know.
Okay, I'm going to, Rowan, I apologize. I have got to start another class in 3 minutes, so it's something I can answer
Yeah, no, it's
relatively
just so
quick.